Okay, so hi everybody, today we're going to learn the laws of indices. So let's start without wasting any time. There are some things I think you should know before starting. So the first thing is exponents. Exponents are the fancy word of power, like 3 to the power of 2 is same as 2 is the exponent of 3. The second thing is base. Base is actually the number that is being multiplied by itself. Like in this example, 2 to the power 3, the 2 is being multiplied by itself 3 times, so 2 is the base. And the third thing is reciprocal. Reciprocal is the kind of flip thing. You flip something around and you get the reciprocal. For example, the reciprocal of 2 is 1 by 2. Now, the logic behind this is that just 2 is not just 2, it is 2 over 1, because 2 over 1 is same as 2. So when we make the denominator the numerator and the numerator the denominator, we get 1 over 2, which is the reciprocal of 2. So I hope you get it. Now let's just move on to our laws here. Yeah. So here's the first law. This law is that if the bases are the same, the pars get added. For example, here's the base A and the base A. Because these both are A, we will write A just once and the pars will add. For example, M plus N. Let's take an example. For example, we have 3 to the power of 4 times 3 to the power of 5, which equals, because the base is same, the pars will get added. The exponents will get added. So 3, 4 plus 5, which equals 3 to the power of 9. So this is a very basic law, something really easy, but never think that this is a plus sign. This is a multiplication sign, and the bases of the exponents get added. So this will never happen. 3 to the power of 4 plus 3 to the power of 5 equals 3 to the power of 4 plus 5. Never. This is absolutely wrong. You must have a multiplication sign here. Okay? So let's just move on. We erase this here. And let's move on to the second law. So the second law is if we have the same basis, for example A, and we have a division sign like this, then the exponents will be subtracted, right? For example, the same example, 3 to the power of 5 divided by 3 to the power of 4. Now because these are being divided, the powers will be subtracted and the bases are the same. So 5 minus 4, which equals 3 to the power of 1, or just 3. So this is the second law of indices. Okay, that was the first one. Now this is the third law of indices, and it states that if we have a power and then a power above it, then those powers get multiplied. I told in my starting videos that when there's no sign between them, we multiply them. Okay, so if A to the power of M is raised to the power of N, then M and N will be multiplied. For example, the same example, 3 to the power of 4, bracket, and 5. Then we will multiply the powers like this. So 3, 4 times 5, which will equal to 3 to the power of 20. Okay, so this is the third law of indices, which states that the powers get multiplied. And the next one. This one is very, very simple. If you have anything to the power of 0, that equals 1. You have x to the power of 0, it equals 1. You have 2 to the power of 0, it equals 1. You have y to the power of 0, it equals 1. Okay, so anything power to the power of 0 is equal to 1. This is the fourth law. The fifth one is that if we have something a base which is raised to a negative power, like this here, then if we take the reciprocal, which I just told at the beginning, then the power will become positive. For example, 3 to the power of minus 4 will equal to, if I take the reciprocal, I told there's a 1 down. So 1 will move up and 3 will go down. So 1 will move up, 3 will move down. And the power and 3 will become positive. If it's negative 4, so it will be positive 4, which is actually the answer. So this is the fifth law. Now the sixth one. I think this is the last one. No. So it is if we have something, let me write in the division format. 1 over n. If we have something in fraction form, then in fact, if you're just looking at the down part here, then this down part, the denominator, becomes the part, like a to the mth part. And to take, for example, we have 16. And when there's no number here, then it is 2. So we can say 16 to the second part. Okay? Okay, so this will equal to obviously 4. So we can say that the denominator becomes the power outside. In fact, this part can be anything, not just 2. 2 is a square root, 3 is a cube root, then you can write 4, you can write 5, you can write 6, you can write anything, okay? And I think this one is the last one now. Yeah, I was right. So if we have a fraction, then the n1, the law we just studied, this one, that here it was m, here it is n, okay? It is that the denominator still comes outside. If it is m, then m will come outside. If it is n, n will come outside. And the numerator becomes the power of the base. So if we have something like 4 to the power of, let's just take 2 here. 2 to the power of 4 over 3, then this 3 will be, first we can convert it, many people convert it to 1 over 3 first times 4, which I think is a bit complicated. So I simply do it that the denominator becomes the power outside, 3, and the numerator becomes the power on the base. Very simple. So I think these are all the laws covered. And let's just do the questions. This is the sixth one. This is the seventh one. Now I've got some questions to solve, to practice, because math is all about practicing. Let's just start with the very first question here. Let's just take another color. Okay, so we've got question number 1, which is 2 to the power of 3 times 2 to the power of 2. So this is the very first law, that if the bases are the same, we add the exponents. So which equals 2 once, and 3 and 2 will be added, which equals 3 plus 2. And this is the answer. Let's look at the second question, which is question number 2. Let's just write it over here, which is 4 to the power of 1. 4 to the power of 1 times 4 to the power of 5. This is again the very first law. When the bases are the same, you write the base once and you add the parts. 1 plus 5, which equals 4 to the power of 6. Wait a second, I didn't solve this here. So this is equal to 2 to the power of 5. And if the question states that what is simplify it, then we can also use the calculator to find 2 to the power of 5. which equals 32, which will be our answer in that case. We can also find 4 to the power 6 in the second question, which is 4096. 4096. And let's do the third question, which is 7 to the power 4. 7 to the power of 4. This is question number 3. 7 to the power of 4 divided by 7 to the power of 2. Now, this is the second law, which states that now because the bases are being divided, then we will write the base once again, 7, and we will subtract the powers. 4 minus 2, which will equal to 7 to the power of 2. Let's do the next question, which is question number 4. This question number 4 is 6 to the power of 5 divided by 6 to the power of 3. Bases are the same, they're getting divided. Write the base once, subtract the exponents, which equals 6 to the power of 2. And let's just calculate them. This is 49, and this is 6 of 36. And the next one is question number 5. Question number 5 is 3 to the power of 2 times 3. So first, 3 to the power of 2. Well, let's just do like this. Because these are out, they're being multiplied, so 3, 2 times 3, which equals 3 to the power of 6, which equals, let me just use the calculator, 729. What's your answer? Question number 6. Question number 6 is 4 to the power of 1 to the power of 4. There's a bracket, so they're being multiplied. 4 times 1, which equals 4, which equals 4 to the power of 4. 256. 256 here. Let's do the next question. Choose a different color, which is question number 7. Seven is 2 times 3. 2 times 3 to the power of 2. Now we are going to distribute this part outside to each one of the bases inside. So 2 to the power of 2 times 3 to the power of 2. We can simply solve that. 2 times 2 is 4, 3 times 3 is 9, and 9 fours are 36. Let's move on to the next question, which is question number 8. Let's just do it over here. 3 to the power of 3 times 4. Question number 8. 3 times 4 power of 3. So again, we will distribute this part to each of the bases inside. 3 to the power of 3 times 4 to the power of 3. 3 to the power of 3 is 27. 4 to the power of 3 is 64. Let me just recheck each one of them. 27. Wait a second. Yeah, 64. And if we multiply both of them, we get 1728. And this is our answer. Let's move on to the next question. Question number 9. Question number 9 says 6 over 3 Again, we're going to distribute this power to both of the bases inside. So 6 to the power of 2 divided by 3 to the power of 2. And we are gonna just simplify them first. 6 6 are 36, and 3 3s are 9, and 9 1s are 9, and 9 4s are 36. Yeah, so 4 is the answer. Next question. Question number 10. Let's do it on this side. Question number 10, which is 8 over 2 times to the power of 3. Again, we're going to distribute this to the powers, to the bases inside. 8 to the power of 3 times 2 to the power of 3, which will equal to 8 to the power of 3 is 5, 1, 2, divided by 2 to the power of 3 is 8. So 5, 1, 2 times 8, 64. So this is equal to 64. And the next question. Question number 11. It is 10 to the power of 0, very simple, anything raised to the power of 0 equals 1. Question number 12, very simple, 100 to the power of 0 equals 1, because anything raised to the power of 0 equals 1. Question number 13, it is 2 raised to the power of minus 3. And, okay, now we have to take the reciprocal, which means we can make it 1 over 2, and now the power will become positive. The power of 3, which equals 1 over 8, which is our answer. I think the last question, yeah, question number 14, which is 3 to the power of minus 2. Again, the very same question, which equals, take the reciprocal and make the power positive. Now solve the power 1 over 9. Which is our answer. So I hope you all get this. Make sure to do some questions on it, and you'll grasp the concept. Go through them, go through the laws of indices again and again, and you'll get them. Thank you so much for watching. Let's meet in the next video. Until then, bye.